Alright, so in this example I'm going to be solving a radical function, and remember, a radical function is just a function that has a variable expression underneath a radical, and the first step for us to solve something like this is to isolate the radical. So we want to get this radical on this side by itself. So we need to get rid of this -2, so we're going to add 2 to both sides. On the left we'll have x plus 2, and on the right we have the square root of 6x plus 39. Once we've isolated the radical, the next step is to raise both sides to the power that will match the index of our radical, and we'll cancel our radical. So since this is a square root, our index is a 2, so we're going to square both sides. And I already put parentheses around this side because I want to square the entire side, not just x and not just 2. I want to square the entire expression, x plus 2. So if I want to square this entire expression, that means I have over here x plus 2 times x plus 2, which means I need to either do FOIL or the box method to actually see what I get here. And I would have x squared, 2x, 2x, and 4. So I end up with x squared plus 4x plus 4 on the left, and on the right my square root and my square will cancel, and I end up with 6x plus 39. Alright, so now I want to solve for x, and it looks like I almost have like a quadratic here. So if I can get this quadratic set equal to 0, then I can factor it and solve for my x's. So I'm going to subtract 6x over to the other side, and I'm going to go ahead and at the same time subtract 39 and cancel both of these. So I end up with x squared, 4x minus 6x is minus 2x, and a positive 4 minus a 39 would give me a minus 35 equals 0. Alright, and now I have a quadratic set equal to 0, so I can go ahead and factor that. So I'm going to use the box method to factor that quadratic, x squared minus 35 and negative 2x. Two numbers that give me negative 35 as their product, but their sum is negative 2. I'm thinking of 5 and 7 would give me 35, and since it's negative, I would want the 7 to be negative, because negative 7 times 5 would give me negative 35, and negative 7 plus 5 would give me negative 2. So negative 7x, 5x, and I can pull out my common factors, x, 5, and negative 7. So I end up with x minus 7 times x plus 5 equals 0 in factored form. So what x values would make this 0? Either positive 7 or negative 5. So these are going to be my solution to my equation. Now, don't forget, when you're solving a radical function, the last step is we actually need to take these solutions and plug them back, not into this equation, but into the original function to make sure that they actually are solutions, because one of them or both of them, they could be extraneous solutions. So let's go plug them back in and make sure that they actually work. So if I plug in 7, on the left I'm going to have 7, on the right I'm going to have equals 6 times 7 plus 39 minus 2. 7 would equal square root of 42 plus 39 minus 2, or the square root of 81 minus 2, or square root of 81 is 9 minus 2, so 7 equals 7. That one, looks good to go. So I'm going to keep 7. Let's try the next one. Negative 5 equals the square root of 6 times negative 5 plus 39 minus 2. So I end up with negative 30 plus 39 minus 2. And that would be the square root of positive 9 when I add these together. So I get the square root of 9 is 3 minus 2. And 3 minus 2 is equal to 1, not equal to 5. So this solution is actually extraneous. We're going to cross it off, and our only solution to this radical function is going to be x equals 7.